Hello everyone. So today we are going to design a very smallest, a very tiny size, this size of GPS tracker, so that you can place this GPS tracker anywhere to track. If you want to track a vehicle, if you want to track your purse, if you want to track a person, if you want to track your kids, then you can track that using that GPS tracker, and its size is very small and very portable, so that you can place it anywhere, deploy it anywhere to track someone, to track any stuff, or to track a vehicle or anything. So today we will design that. So before going deep inside the design thing, how we can design, let me show you the demo of that, and let me show how the device look. And there are two versions of actually it. One is the Wi-Fi West. So in Wi-Fi West, it will give you the tracking location on the phone, on the web app, on the website. If you give you the link, when you click on the link, you will get the tracking details, the real time location on the Google Maps. And another thing, another version is GSM version. In GSM version, the tracking location being sent by the using the message to your phone. So suppose that you have make that tracker for the kid. So whenever you want to track the kid, where your kid is right now, at what place, then you can simply open the message on your phone that is being sent by the GPS receiver with the real time location. uh, and when you click on that link on your phone, it will show you the location, real time location of that kid, or anywhere where you have deployed it. So there are two versions of it. So let me show you the demo of that thing and how the device looks. So here is the device. I Let me show you the device first. So So as you can see, here is the device. This is a device. This is very tiny size device, a very tiny, like this one, like this kind of device, that is very tiny. It's fit around the, as you can see, around my finger, in half of the finger, not even the half. It's very small, 3 centimeter size GPS tracker. So it can fit inside the keyring, like you can keep it as a keyring, or you can attach it as a tag to your kit, or you can keep it in the vehicle anywhere, or in the purse anywhere, and it will give you the tracking data and details. So this is the device, and this is a GPS antenna and GPS module with the device and giving the real time location. So this is the device. This is how our device look, and this is how the Wi-Fi based thing will look. Here is the device, and here is the Wi-Fi thing. So as you can see, here I have the device. Here I have the device, and it is giving the location on on this web page in real time. As you can see, 1 minute. As you can see, when I refresh this page, see, I refresh this page. It is giving the location and direction as well, which direction it is in. So if I move, the direction will also change. So when I click on this link, I will get the real time location on the map. Check, see. Let me enlarge it. See. So this page will automatically refreshing, and I can also refresh it manually, and it will give you the link of the map for the location. And when I click on that link, it will open the Google Map and show me the real time location. See, it is showing my real time location here in the home. See, so this is the device. This is the device. This is the device. 1 minute. So this is the device, and this is the web page. This is the web page. If I suppose that it works on the battery and the USB power as well. So I am right now, it is on the battery. If I move this device, see, the magnetometer data direction will also update. See, if I move it to the northwest, the northwest. If I move it to the north, it will direction will become the north. So it will also tell you the direction at which, in which direction you are going, and at what location you are at. So it also give you the direction. Like, unlike other GPS, they don't give you the direction. They only gives you the unlike other GPS, they only give you the GPS location, not don't give you the direction and the movement data. But it also give you the movement direction, movement data. See, I move it here. I move it in north direction. I move with northwest, I move with in other direction, it will moving the same, and it also showing the movement data and all other data. See, in real time. And whenever I click on this, it will give you the location, accurate location. So this is the web page based location tracker. Now what about the phone? So it will also send you the this device will also send you the real time location of your kid, or wherever you deploy this device. So it will also send you the real time location on your phone or using the message. So at every 5 second, 10 second, whatever the second you have set in the code, it will send you the location, and you can also get the location by sending the message get location to this device. And when this device receive that message, and it will send you the real time location. So here is my phone, and here the device is sending the location. So when I click on this, you can see it is sending my location in real time. See, all these are location which sent by this device. See, so when I click on this, I will get the location in real time in the Google Map. See, Google Map open with the real time location. So where is this device is? So this is how this device work, and this is how tiny this device look. This device is. And if you want to add any display like this OLED display to display the location on the device, or status anything, then you can also add the OLED display or any other display to this. And this is very tiny, as you can see. You can compare with my finger, you can compare it by my small finger. This is very small finger, and it is size this, because and this whole device is made on this Indus board, and combined with a small GPS receiver, a small GPS module, and SIM 808 or SIM 800L module. So using the SIM 8008 or SIM 800L module, if you are using SIM 800L module, then you can insert the 2G SIM card to the device, and it will send you the location on the phone, and you can track the real time location. But if you are using same 808, then you can insert the any Geo or any 4G SIM card inside that module, and it will send you the real time location on your phone like this. So I can get the real time location. And you can also get the location by sending the get loc. And along with the location, if you are using the web page based system, then along with the location we will also get the this direction as well. See, if I move, I move, if I move this, and then the direction will be also change here. See, along with this I need to refresh. Yes, see, the direction get updated. So it is very real time GPS location, and its size is very small. This is small. So let me tell you how you can make this device. So if you are making the Wi-Fi one, this web page one, then what you need, the component that you need is this Indus board, one of these Indus board, and one GPS module only. And your real time GPS location, Wi-Fi based real time GPS locator, which is ready. And if you are using the GSM based, then along with this you also need a GSM module SIM 800L. So here I've used the Indus board, and the small GPS module, and one SIM 800L module, and one SIM card for 2G or 4G SIM card according to your GSM module compatibility. If you are using the SIM 800L, then you need a 2G SIM card. If you are using a SIM 808, then you can insert 2G to 4G SIM card. So all those SIM card are compatible with those module, and it is acceptable for many countries. The same band, it can be accepted for the many. So this is how the small device is looking, and this is how you can track uh, using the message. It is sending me the message in real time on my phone, or location data. And whenever I click it, it will open the Google Map and show me the real time location of this device. And it will also give you the this kind of web page if you are using the web page based system. And it will give you the location data on the web page, and whenever you click this link, it will give you the real-time location. So this is how, and this device is very tiny, so that you can implement it anywhere, you can attach it anywhere to track anyone. If you can attach it like on the kid bags like this with a keyring, and it will track the kid and send you the location. It will, you can attach it to any parcel, you can attach it to any cargo ship, you can attach to the vehicle to track the vehicle. You can implement it this anywhere to get the real time location on the map, and this device is always sending the real time location, this device is. So let me tell you the components that you need again. So first component you need is the Indus board. This Indus board you need this Indus board. One Indus board is needed, and then a second component is needed for the Wi-Fi based is this GPS module. If you're making the if you're making the device like this one, a Wi-Fi based tracking system, but if you're making the system tracking system with the SMS based system, where you get the location, real time location from anywhere in the world in the form of SMS, is SMS showing the real time link, then you can add the SIM 8008 or 800L module. And if you want to show that other data along with this tracker, then you can attach the SSD 1306 or other similar display, a display like this one, a display like this one. So the main component for the basic GPS receiver is Indus board, one Indus board, and another component is this SIM 8008 or 80L. If you are using this kind of SMS based GPS tracking system, this kind of SMS based GPS tracking system, and if you are using the web based GPS tracking system, then you can eliminate the SIM 8008 or SIM 80L. So for the basic one, you need a Indus board and this GPS module, one GPS module. So this GPS module is L86 from Cortel. It comes around 800 sorry 500 to 600 rupees, and this Indus board comes around 1500. So around 2000 you can make a basic GPS tracker. And if you want to add the GSM module as well, so around 300 to 400 you can add. So around 250 to 2500 or 2300 you can make a whole GPS tracking device that will send you the GPS location on the phone, that will send you the GPS location on the web page, and you can track the device, or you can track the kid, or you can track any trucks in the real time. And this is very smallest, this is very small, this is just this tiny size, around 3 centimeter only, around 3 centimeter only. So these are the components needed. So let me tell you more details about the GPS module I have used. So the GPS module I have used is L86 from Quartel. This is the 1 minute, let me tell you, show you the data sheet of that. Yeah, so this is the data sheet of the GPS module I have used. 1 minute, let me open it again. So this is the data sheet of GPS module that I have used. uh, uh, according to data sheet you can see these are the pinouts, and this is the module that I have used. Its size is very small, that's why I have choose the GPS module name is L86 from Quartel. uh, 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 and this is L86 module. This is this tiny, you can see. It's around, you can see in the camera, if you're seeing the camera here, its size is very small. As you can see, this is the size, total size of the GPS module, around 3 centimeter. And this is the size of GPS module I've used, around 1 centimeter, 1 or 1.5 centimeter. So around 1.5 centimeter the GPS module is, and total whole device size is around 3 centimeter. So this is that's a small. And this The data sheet, according to the data sheet, it works on the RxTX serial port, and you can power it using the VCC and ground. It also have a backup to keep track of time, and also get the real time location if the main battery fails. So you can also add extra battery to this. Otherwise you can leave it, you can connect it directly. If you don't add using the V backup, you can connect both thing directly. And the whole this whole module consumes only around 1 minute. Let me tell you, the you can power this device from 2.8 volt to the 4.3 volt in the range. It can work in all those range. So if you have 2.8 watt battery, then this GPS module will also work. If you work if you connect it with 4.3 volt, then it will also work. If you connect with 3.3 volt, then it will also work. And it only consumes around 100 milliamps, so it's very a small amount of current that it is using. So it's also the power efficient. And here is how you need to connect the V backup battery. If you are adding the V backup battery, if you are not using the backup battery, then you can simply connect the sort these two pins on the module. So here is the final connection diagram of this whole device. So if you are using the OLED display as well to display other connection data and language it, then you can add it. Otherwise you can ignore this one. So here is the main board, the Indus board, that have the Wi-Fi and magnetometer compass sensor inbuilt on the board, and many other sensor that is already inbuilt on the board. So there is the Indus board, and this Indus board is connected with the GPS module, and this GPS module is connected with the serial port of RX TX pin. So this RX pin connect to the TX pin of the GPS module, and TX pin connect to the RX of the GPS module. RX of the GPS module, and this board have the multiple number of hardware serial ports. So you can you can define any of these pins and use this any of this pin as a serial port and multiple serial ports. So one serial port I have used it 43 44 pin number, and other serial port I am using is for the GSM module is 40 and 41. So here I have used the SIM 800L GSM module for sending and receiving the message between the and communicating with the GPS tracker device. So that this device will send the location, get the location. This device will this the Indus board get the location from the GSF GPS module, and then this send the location to the phone using the GSM module. So this GSM module can work on 3.3 volt, and so you need to connect this 3.3 volt VCC to the 3.3 volt of the Indus board, and the ground to the ground of this Indus board, and RX to the 42p RX of this to the hardware hardware TX of the Indus board, and hardware TX of the Indus board to the RX of the GSM module. So here are the two serial ports that I have used. RxTX is inbuilt hardware serial port, and 41 42. You can use any of these pins, available pins for the serial port. Any you can define that in the port. And I have connected these two modules. One is the GPS module, and other is the GSM module for getting the data of location and sending the location data over the phone, or over using the message to the phone. And you also need one 4G or 2G SIM card as well. And if you wish to add a SSD OLED display to show the to show the details, then you can also add the SSD OLED display on the pin number 8 and 9. And this for getting the direction, at which direction you are moving, and at which direction it is currently the device is facing. For that you don't need any connection. The Indus board itself by default have the accelerometer sensor, magnetometer sensor, and the temperature sensor. So you can get the direction using the magnetometer sensor and the motion as well. So like this, here the magnetometer accelerometer data is showing, and here it is showing the location in the map in the real time. See, it is showing the device location in the real time on the map here. So this is how you need to connect, and after connecting, your device will look like this. So this device is very small. So for that you need to solder it. Let me tell you how to solder it. So here is the GSM module, and here is the Indus board. So on the back side, or on the top, you can attach the GPS module, and over the GPS module you can attach the OLED display, and the CMate00L module, like this display, this display, and the CMate00L module on the Indus board, like this. So after soldering all the components like this, connection diagram, your device will look like this. And then you can attach the battery. So this is the whole module, and you can attach any circular battery around this, or you can use this battery as well. And your GPS tracker is ready. You can also use a small circular battery, but I don't have that circular battery, so I'm using this one. So the GPS module is connected to the soldered with those pins, and GSM module also soldered with those pins, and the you can fit whole modules in this type of case, or in this type of size, and your GPS tracker is ready. Or you can also put it with the inside the case, like this one, like this one, like this one, like this one. So this is how your final device look, and this is how your final device look, and this is how it will send the message to you regarding the location. And whenever you tap on this, you will get the real time location of this device. And this is how you need to connect it. Now let's talk about the coding. So for the coding thing, here I have created the code for that. So in the code, first you need to define the GPS serial port number, and then you need to define the baud rate. So the this GPS device work on default baud rate of 9600. So you need to use that baud rate, and then you need to define the baud rate, serial port, and the baud rate for the GSM module. So it will work on 4800 baud rate. The GSM module work with on the 4800 baud rate. And for sending and receiving the SMS from the GSM module SIM 8008 or SIM 800L, you need a library. The library name is async SMS. So you can simply copy this and paste it here, async SMS, and you will get the library, and install the library. After installing the library, and defining the pin numbers of the GPS module, and the baud rate of the GPS module, and GSM module or baud rate of the GSM module, you can begin the serial communication. And after getting the serial communication, you can create a loop where it will check the network status, whether network is on the SIM inserted on the device, have the network or not. If the network is on, then it will go to the this while condition, where it will check if the data is coming from the GSM module, from the GPS module or not. It will extract the location data, and after extracting the location data, call the SMS helper process function. And up on the in the SMS helper process function, it will it will check if it had get any new message or not. If you send any message to the device get LOC, then it will send you this the location. Otherwise it will keep sending you the location with the interval of 2 minutes. So after every 2 minutes it will send you the location or the device location on your phone. And after this you need to upload this code. And after uploading the code and connecting the components according to the circuit diagram, your device is ready to track like this, to track like this, to track like this, track like this. So this is the main device, this is the main device, and this is the phone. And on the message you will be receiving the, you will be receiving the location, you will be receiving the location like this. You will be, sorry, you will be receiving the location like this. So whenever I click on that, I will get the real time location on the Google Map. So this is how you can make the a smallest, this is very smallest. So this is how you can make a very smallest or design your own very smallest GPS tracker. And you can redesign the whole thing on the Indus board and make a device and sell in the market as well. After getting some certification and doing your own, creating your own firmware, you can make a small GPS tracker and sell in the market at that cost. That, and the whole design can be made around 2000 rupees or 2500 rupees, the whole GPS tracker you can make. So thank you everyone. I think you all have lots of learning from the session. If you need any more question and you have any more doubt, then let me know. Anyone have any doubt, any question, then let me know. Okay, thank you everyone. Bye. If you have any question, we can take it later. You can comment the question on the project. The whole project is published on electronics4u.com, so you can check the project soon. After next week, the whole project will be published on indus.electronics4u.com or electronics4u.com, and you can check there the whole project and the code. And if you have any doubt, you can check in, you can ask in the comment after the live as well. So thank you.